Welcome back. This is lesson 1 on the topic of factorizing third-degree polynomials. Okay, for polynomials, you've already seen them before. An example of a polynomial would be y equals 2, or y equals 2x plus 1, or y equals x squared plus 3x plus 1. Another one, y equals x cubed minus 2x squared plus 5. These are all examples of polynomials. The first one is called a constant polynomial. The next one, you might recognize this. This is a linear polynomial. This one is a quadratic. You can see the power 2. So this is a quadratic. It's a quadratic polynomial. You may not have seen this last one before. This is a cubic polynomial. Okay, notice we have powers here of x. This here, 2, is actually x power 0, because anything to power 0 is 1. So in this case, we normally don't write x0 in a polynomial. This one is power 1. That gives it the name linear. This is power 2, which makes it a quadratic. And this is power 3, which makes it a cubic. So before we go too far, we should do a quick revision of what factorization is. For example, what are the factors of 36? So what I want to know are what are two numbers, whole numbers, that when you multiply, you'll get 36. What do you think they are? We could have 1 times 36, 2 times 18, 3 times 12, 4 times 9, and the last one, 6 times 6. Okay, so all of these numbers are factors of 36. How about the prime factorization of 36? You probably saw this in grade 7 or 8. I think grade 7 actually. So 36, let's make a factor tree. 36, we know 36 is 4 times 9. But then 4 is 2 times 2. And 9 is 3 times 3. So we write 36 as the product of the prime factors. 2 times 2 times 3 times 3 equals 2 squared times 3 squared. So that's called the prime factorization of 36. The factors are prime numbers. 2 is a prime number, 3 is a prime number. What we'll do now is factorize some basic expressions. If we can. Maybe we can't factorize. Where possible means you may not be able to factorize. So let's look at these. So we've got c squared plus cb. One way to do it, you could write out c times c, which is c squared, plus cb. And if you notice, what are the common factors? We have a c here, and we have a c here. So we take that c out and put it in the front. And what are you left with? C here plus b here. Okay, so now you factorize that expression. You can check it by multiplying again. So c times c is c squared, and c times b is bc, or cb, same thing. So you can check it by expanding back to the original expression. In this question, we have 3x squared minus 9xy. What are the common factors? We have 3x squared, so 3x minus 9, which is 3 times 3 times x times y. So look for your common factors. We have a 3, we have a 3, we have an x, we have an x. So these are your common factors, 3x. And we write them out the front like that. And then whatever is left over goes in the bracket. So we have an x here, an x minus, and we are left with 3y, like that. And again, check by expanding. In question C, we should expand this first. So dx minus dy minus d squared. So your common factor here is going to be d, isn't it? You have a d here, you have a d here. You actually have two d's here. So we take one out. So we have d, d, d. So write the d here, and you are left with x minus y minus d. There is one d left here because d times d is d squared. And one of them was taken out as your common factor. In question D, we have 16x cubed minus 8x squared. Okay, so the common factor here you see will be 8. And we have an x cubed and an x squared. So the lower power is x squared, so we take out x squared. You would be left with 8 times 2, 2 8s is 16, x squared times x power 1, which we don't write the 1. And then we'll be left with minus 1. 8x squared times 2x is 16x cubed, and 8x squared times minus 1 is minus 8x squared. So you can see we did it correctly here. In question E, we have 3 terms, which is okay. We look for common factors. 2 is not common because we have a 3 here. We have a squared, a. So let's take out a. We have b here and here, but not here. So b is not common. And there is no c here. And there is no d in these two. So a is the only common factor. So I'd be left with 2ab minus 3b squared c plus 4cd. And just inspect carefully, there is no more common factor that was missed here. So this is your final answer. In question F, we have 2a cubed minus 4a squared y. So 2 looks to be a common factor because 4 is 2 times 2 here. So 2, and we have an a squared and an a cubed. So take out the smaller power, a squared. So 2a squared times a is 2a cubed. 2a squared times what is minus 4a squared y. So that would be minus 2y. And again, check by expanding. 2a squared times a, 2a cubed. 2a squared times minus 2y minus 4a squared y. Okay, so that's your basic method for factorizing. In this section, this is called the difference of squares factorization. Okay, and we'll do this more later because we need it later. So the general rule is a squared minus b squared. When factorized, will be a minus b, a plus b. So let's check that. A minus b, a plus b, and let's expand it. So a times a is a squared. A times b is ab. minus b times a minus ab, and minus b times b minus b squared. You'll see you have ab and ab here, and they are subtracted, so this becomes 0. So you'll be left with a squared minus b squared. And that's shown in the rule here. Okay, so an example of using this rule, we have 16 minus x squared. So what you're looking for are powers of 2 and a negative sign, a minus sign here. If it's plus, we don't use this rule. It must be minus here. Notice that 16 can be changed to 4 squared. So we write 4 squared minus x squared. And now we have it in the correct form. So a squared minus b squared is a minus b, a plus b, or x minus 4, x plus 4. If you expand that, you should get back to this original expression. In this question, we have 4x squared minus 25. Try to make this powers of 2. 4 is 2 squared, x squared. 25 is 5 squared. 2 squared x squared can be written as 2x all squared. It's the same thing because we have a rule, a squared b squared is ab all squared, like that. So then we have 5 squared. So then we use our rule, a squared minus b squared. So a minus b, a plus b, like that, where a is 2x and b is 5 here. That's a and b there. Okay, so we're going to do more on this topic a little bit later. In this part, we'll do factorizing by grouping. This is another method, and especially when we have 4 terms, like in this example here. So it doesn't always work, but we try. So look what you have here, 3x times p minus 2q minus 2y p minus 2q. What you should notice is that we have a common factor here. Okay, so that p minus 2q can be written in the front, p minus 2q, and put in brackets. So we move it out to the front. And what are you left with? 3x here and minus 2y here. In this question, I can see I've got 4 terms, x squared minus 3x and minus xy plus 3y. What I'm going to do is I'm going to factorize the first pair. So I'll be left with x minus 3 here. Check, x squared, x times minus 3 minus 3x. Minus, a common factor here would be y. You see you've got y here, so I take y out, and I'm left with x minus 3. Why is it x minus 3? Take a look. Minus y times x, minus xy. Minus y times minus 3 is plus 3y, okay, because 2 negatives make a positive. So in this kind of question, you need to be careful with the sign here. But what you now see is now I have the common factor x minus 3. So I write my common factor out the front, and then I have x minus y as the last factor. So you're probably wondering, how can we factorize something in this form? X cubed minus 27. The name cubic polynomial comes from this number. That number is called the degree. the degree of the polynomial. Okay, and if it's power 3, if 3 is the highest power in the polynomial, it's called a cubic polynomial. We have this form where we have x cubed minus a number, or it could be plus as well, which we're going to do later as well. So now we'll look at what's called the sum of cubes. So sum of cubes could be written as something like x cubed plus 6 cubed. Notice how we say it, the sum of the cubes. And these two numbers are cubes. And in the second rule, we have difference of cubes. So in that case, this will be just negative. Okay, that would be difference of cubes. So now we'll try to show how this is done by algebraic methods. So I've got a cubed plus b cubed, the sum of cubes. What I've done here is I've added two terms which actually cancel to 0. A squared b minus a squared b. So I've done that so I can do some factorization. A squared b minus a squared b is 0, so they are still equal. So I'll factorize the first bit. I've got a cubed plus a squared b. So a squared is the common factor. I would be left with a plus b here. In the next one, I've got a squared b plus b cubed. So it looks like minus b, and then I've got a squared minus b squared here. Okay, let's check. Minus b times a squared minus a squared b minus b times minus b squared is plus b cubed here. So we can note here we have difference of squares. So we can factorize this. So I've got a squared, a plus b, minus b. Now a squared minus b squared, as we know, is a minus b, a plus b. There. And you will note now we have a plus b as a common factor. So this a plus b, we write in the front, a plus b here. What are you left with? We've got a squared and this part here. So we would have a squared minus b times a minus b times minus b is plus b squared. So these are your factors. So we have a plus b, and we have a squared minus ab plus b squared. And that is a cubed plus b cubed. So we'll highlight that there. That's your rule. So a cubed plus b cubed is the same as a plus b times a squared minus ab plus b squared. Okay, for difference of cubes, we can do it the same way, except this time we swap the two numbers around. So we have minus a squared b plus a squared b. When you add them, again, you get 0. So we still have these two sides being equal. So we'll try to factorize each part. So here, the common factor is a squared I would be left with A minus B. In this part, the common factor is B. So plus B, and I'm left with A squared minus B squared. So you'll see here now we have our difference of squares again. So we have A squared, A minus B, plus B times A minus B, A plus B, like that. Notice now we have the common factor. So let's take that out, A minus B. That goes in front. And what are you left with? You're left with A squared plus B times this number. So then we'll have A squared plus B times A plus AB plus B squared. There. So we can conclude that A cubed minus B cubed is A minus B times A squared plus AB plus B squared. So, and that's our final factorization there. You should note normally this bit here cannot be factorized again. So usually the second term can't be factorized further in either of the difference or sum of cubes. So here's a summary of the two rules, A cubed plus B cubed. They're not that hard to remember. You've got a plus here. This sign is plus. So this is the same. Okay. So minus sign here. But notice now we go to the opposite sign. So plus becomes minus and minus becomes plus. So that's the opposite sign. Now in the last sign, it becomes plus plus. So they're both positive, all positive, all positive. So same, opposite, all positive. And that's the way that I remember the signs. So be careful with that. Now, one remark here, any exponents which are divided by 3, for example, x cubed, x6, x9, can also be factorized using these rules here. And we're going to see that quite soon as well. Okay, here's some examples that will help you with the questions in the book. We want to factorize x cubed plus 8. So we only have two terms, x cubed and 8, and we know 8 can be made as a cube. So we would write that as x cubed plus 2 cubed. Okay. So from our rule, x plus 2 will be the first factor. Then the second one would be x squared. So we have same sign. And now we go to opposite sign. So then we would have 2x. And then we go to all positive, and that would be b squared. So this will become 2 squared. So you're going to get x plus 2, x squared minus 2x plus 4 as your factors in that question. In question B, notice the 64 can be written as 4 cubed times x cubed minus y cubed. So now we put the 4x into a bracket. 4x all cubed minus y cubed. Okay, but don't forget to put this all into a bracket, and they are both to the cube, so 4 cubed x cubed. So then we have, when we factorize, we have the same sign. So now we have negative. So we're going to have 4x minus y times this term squared. So 4x squared, same. Now we go to the opposite sign. And then we multiply 4x times y. And then the last term squared. So that will be y squared. So we got 4x minus y as the first factor. Then we got 16x squared plus 4xy plus y squared as the last term there. Okay, so these are your two factors. In question C, notice we've got an x4, it's not x cubed. And you may be thinking you can't do it, but you notice that we also have x here. So you should always look if you can factorize basically first. So take out the common factor x. So you'll be left with x cubed minus 64. Okay, so now we can do it because 64 is 4 cubed. So we'll have x cubed minus 4 cubed. And this part can be factorized as the difference of cubes. So then we'll be left with x. Our first factor will be x minus 4. And then we have the same sign. Now we go to opposite sign, and x squared plus 4x plus the last term squared. So 4 squared will be 16. Okay, so these are your, now you have three factors. You've got x here, x minus 4, and x squared plus 4x plus 16 here. So that actually has three factors. That one. In this question, we should also look for a common factor between the 3 and 192. So 3 would be the common factor here. Then you'll be left with 64 m cubed plus n cubed. Okay, you see how I took the 3 out from both parts. But then the 64 would become 4 cubed. So 3, 4, m all cubed plus n cubed there. Just leave the 3 by itself. It doesn't come back in at all. Just leave it sitting in the front. So then I've got 3. What would be our first factor? 4m plus n. The same sign as that. So 4m plus n. Then the next part will be 4m squared. And now we go to a minus sign, and then 4m times n. And the last term squared. Like that. So this here will just become 16m squared, and you can write that in there. In question E, we look for another common factor, y and y. So let's take that out first. Y, x cubed minus 125. That's good because 5 cubed is 125. So y, x cubed minus 5 cubed, which is 125. And now we have our difference of cubes. So y, x minus 5, then x squared plus 5x plus the last term squared. So 5 squared would be 25. And those are your three factors. You have y, x minus 5, and this last factor here. In this question, we see that we're going to have the common factor 7 that we take out first. So 7 eighths of 56, x cubed minus b cubed. So now we should change the 8 to be 2 cubed. So 7, 2x, all cubed, which is the same as that, minus b cubed. Okay, now we can do our factorizing with the rule. So 7, 2x minus b. And then we're going to have 2x squared plus 2xb plus b squared. So we're going to have 7, 2x minus b, 2x all squared is 4x squared, plus 2xb plus b squared. Okay, these are your three factors. Well, the first one's just a constant anyway. So take a look at those examples and then try the questions in the book and let me know if you have a problem. So good luck with that.